Welcome back to a new machine learning tutorial. In this video we are going to be talking about the voting classifier. We are going to be talking about how it works, and then we are going to be coding it using Python Scikit-Learn. Let's start coding. I'm in VS Code right now. I will be using Visual Studio Code, but you can use any code editor that you want. I'm going to be closing the welcome page we have, and then I'm going to creating a file like voting classifier. .rpmb for creating a Jupyter notebook, and I will select my kernel as 3.11.4. Then I will say voting classifier, our title, and let's talk about it. So voting classifier combines multiple base classifiers to improve overall predictive performance. So our goal is improving the performance. It works by aggregating the predictions of each base classifier and making a final decision based on a majority vote or average. Majority vote for classification, average for regression. This approach often yields better results than any single classifier alone by leveraging the strengths and compensating for the weaknesses of individual models. So in this tutorial we will go step by step and see how we can use voting classifier. So firstly we need a dataset. So I will say Scikit-Learn datasets. We are going to import from here, from Scikit-Learn datasets, import make classification, and then I'm going to import pandas as pd and import numpy as mp, and we are going to create our data with this make classification feature we have. I will say x and y, and I will say make classification number of samples. It's going to be a row count, let's say 1000 for this, and next we need to specify number of features, let's say 20. This means that we are going to have 20 x columns. And then I'm going to say number of informative, and it's going to be 15, and number of clusters per class is going to be 2. And now we have our data. I'm going to call x, we have a matrix like this, and I'm going to call the y, we have a vector like this, and we can see that we have a binary classification problem since we have zeros and ones at target side. Now what I'm going to do is I'm going to be creating a data frame with this. So data frame is going to be pandas data frame x, and for the column naming, let's say I want to go like feature 1, feature 2. So for the columns I will say I will use an f string feature, and I will use I in here like this. It's going to be in a dynamic structure for index in range x.shape, and I will say 1. So when I call the data frame, we are going to have our features like 0 to 70, and I will go right 19. Okay, we have 20 columns starting from 0 to 19, and now we need to add our target vector into this. We will say data frame target is going to be directly the y vector we have, and here is our data frame's new version with 21 columns and 1000 rows. Great. Now let's import our classifiers. I'm going to be using 4 in this video. I will be using logistic regression, decision tree, random forest, and support vector classifier. Firstly, I will be using a for loop for evaluating their performance. I will say from scikit-learn.model selection import cross validation score. Then I will say from scikit-learn linear model, our first model is going to be logistic regression like this, and our second model is going to be tree based one, decision tree classifier. Then our third one is going to be random forest from scikit-learn.ensemble random forest classifier, and our fourth is going to be scikit-learn support vector machines import support vector classifier. So we have our classifiers right now, and now I'm going to set them like classifiers, actually lowercase letters, classifiers, and I'm going to create a dictionary. I will say logistic regression, and I'm going to initialize it in here, and then I'm going to be saying decision tree and I will say decision tree classifier. Then I'm going to say random forest, and I will say random forest classifier. Lastly, support vector classifier is going to be like this, and we have it right now. Let's create a for loop quickly. For name and classifier in classifiers dot items. Let me quickly show you what we are going to be doing. Print name, print classifier. So we are going to have logistic regression to support vector classifier to SVC in here. And now in the for loop, I'm going to be doing like scores is going to be cross validation score classifier x, y, and let's set cross validation as 5. This means that we are going to be having 5 folds, and I will say print. I will use an f string. I will say name, firstly name, then I will say mean accuracy, and let's use like scores dot mean, and I will say to float like this. I'm going to be correcting that quickly, and this is what we are going to have when we run this for loop. So we can see that we have the accuracy of 0.76, accuracy of 0.79 in logistic regression and decision tree, and random forest we have the 0.91, support vector classifier we have the 0.93. And by using a voting classifier, we are not going to guarantee that it's going to be always more than the support vector classifier, but it's going to be more than the mean of them 100%. Like, let me also call the mean on this, like values for mean empty list, and we can do like values for mean dot append, and we can say scores dot mean like this. And now I'm going to call values for mean. We have these values, and I will say numpy dot mean. I'm going to be calling that we are going to have a value greater than this at 99% of the times if we use these models. So by the way, it can be a Q2, it depends. And let's train a voting classifier. In voting classifier, we can use either hard or soft voting. So in the hard voting, class label with the majority vote is selected, and in the soft voting, probabilities of the classes are averaged, and highest average probability is selected. We can do both, but I will be going with the hard voting in this tutorial. So I will say from Scikit-Learn ensemble import voting classifier. Then I will say voting classifier is going to be voting classifier estimator is going to be, we are going to give a list on the estimator side, and not like this. Let's go like this and create on here. Now I will say linear regression, and I'm going to say logistic regression. By the way, I missaid it. It's logistic regression, LR. When I say LR, I automatically think of linear regression. They are both linear models, by the way, so it's not that wrong, but it's logistic regression. And decision tree. Next, we are going to say random forest, and it's going to be random forest classifier, and we are going to have support vector classifier. We will say SVC like this, and now we are going to end our list like this in here, and we will say voting is going to be hard. And now we need to remove this extra AQ sign in here, and it says there is a problem. Yes, I need to fix this. Now we have it smooth. Okay, so I will say voting classifier, and I'm going to be train the voting classifier using fit. I will pass X and Y, and we have our voting classifier in here. Now I will say scores is going to be cross validation score, voting classifier X, Y, and cross validation is going to be 5. So our result is going to be in here. I'm going to make it run, and let's print scores. And we have these scores. And let's get mean of all of our fault scores, like I will say numpy.mean scores, and we have the mean of 0.89 on all faults. So what was it? On the base models it was 0.84, and now we have 0.86. Great. So we improved our performance by using voting classifier, and the primary purpose of using a voting classifier is to improve prediction accuracy by combining the strengths of multiple models. Each base classifier might have its own strengths and weaknesses depending on the data. By aggregating their predictions, a voting classifier can mitigate individual models, biases, and variances, leading to better overall performance and robustness. This approach helps in leveraging the diverse perspectives of different classifiers, often resulting in improved generalization and accuracy compared to any single model. Let's summarize what we do in this video. So we firstly talked about the voting classifier and what is that, and we create the data. Then we create the data frame with the data we created, and we have our data frame right in here with 20 x values. Then we added the y target in here. Now we have 21 columns and we are ready to train our models. Then we imported cross-validation score and we imported the classifiers we have, and then we initialized classifiers on a dictionary like this. Then we checked the mean scores on the models. Like in here, what we do is we go in this dictionary and we train our models with using cross-validation score. Basically what cross-validation do is, let's say we use the cross-validation 5 like this, and we have 5 data points like this. It works like it trains the model with the first 4 and tests with 5. Then it trains the model with 1, 2, 3 and 5, then tests with 4. These are going to be our faults. And it trains the model with 1, 2, 4, 5 and tests with 3, and it gets 5 scores for 5 faults. Then we get its mean and print in here. I also get that model means in here for checking the average performance of models. And we see that we have the 0.84 on that side, and then we talked about the hard voting and soft voting. Then I imported voting classifier from Scikit-Learn.ensemble. I used the voting hard technique. The class label with the majority vote is selected, and we initialize them in here like this on the estimators, and we set the voting hard, and this is the voting classifier syntax. Then we train the voting classifier and we get the mean score, and we saw the improved performance. Thanks for watching this tutorial. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.